Okay, kids, this is Circle Geometry Unit Day 4. Okay, here are some things that we're going to become familiar with throughout this unit. Outside times the whole is equal to outside times the whole. Okay, and so I think we saw a little bit of that. No, we did not. That is a different part. Okay, we have not seen this yet, and we have not seen this yet, but we do know what this is. Okay, we've seen Pythagorean theorem. And this is where we're going for the beginning of the lesson. I'm going to introduce tangent to the radius. So, tangent to a circle. A tangent is a line which, no matter how far it is extended, intersects a circle exactly one time. Diagram shown, line M is tangent to circle O at point A. Okay? So it crosses, this line intersects this circle at exactly one point. So in circle A, shown below, lines M and N are tangent to the circles at points B and C, respectively. So it says, draw in the radii AB and AC. Okay? Drawing those radii. So, what appears to be the relationship between the tangent lines and the radii? Okay, so take a look at these lines. And see if you notice that there's anything formed between these two. Anything special that is formed from these radius going to the tangent line. So if you haven't noticed it yet, okay, if you take a look, these radii are perpendicular to both of those tangent lines. So what appears to be the relationship between the tangent lines and the radii, they are perpendicular, okay? Which means they create a 90-degree angle. All right, which is basically all you really need to know on that. So the radius, when they come out and touch this point that's on these lines there, they form a 90-degree angle. So they form a 90-degree angle with the tangent line. So the shortest distance from a point to a line is the length of a perpendicular segment drawn from the point to the line, okay, which we have just seen above. So in exercise 3, it says in circle K, segment AB is tangent to the circle at point A if the radius of the circle has a length of 5 units and the tangent has a length of 12 units. What is the length of KB? Okay, so AB is tangent to the circle at point A, which means it touches this circle exactly once. Okay, so there's AB, and we know that the length of the tangent is 12 units. In this case, our tangent is AB, okay? And then they give us the radius is 5, which means K to A is 5 units. So the only part we need to find is this piece right there. So we know that also that this radius and this, so KA, write it out here, is perpendicular to BA. Okay, so we say a 90-degree triangle or a 90-degree angle, which means we have a right triangle, which means that to find this other length, you've guessed it, we have to use a squared plus b squared equals c squared. Okay, so this length right here is always located directly across from your right angle. Okay, so in this case, they give us A plus 12 is B, or plus 12 squared equals C squared, so we get 25 plus 144, which is 169, it's equal to C squared. Take the square root of 169 is 13. Whoops. Okay, so this side right here is 13 units. Okay, and we found that just by using Pythagorean's theorem. But basically what you want to take from this piece is that these radii, okay, these radii form a 90-degree angle with all tangent lines. Okay? that's what you need to take from that. Okay, let's scroll down to, here's your homework. Okay, so try to give these ones a shot. Okay, try to figure out what, determine if line AB is a tangent. So in this case right here, we take a look. Okay. So in order for it to be a tangent, okay, we need this property to hold true. So in this case, 8 and 12 is equal to 20. Okay, that represents that length right there. So the only one we don't have is this one down here. So we got 16 squared plus b squared is equal to 20 squared. Okay, because don't forget, right, your hypotenuse is always located directly across from your right angle. So in this case here, 16 squared is 256 plus b squared is equal to 400 squared, or 400, which is 20 squared. So 400 minus 256, you get b squared is equal to 144. Take the square root. B is equal to 12. Okay? So that's what you're trying to make sure of. By make sure of, I mean that these things line up. Okay, so in this case, 16 squared plus 12 squared equals 20 squared. So let's take a look at this one over here. Okay, so 13 represents our hypotenuse, right? Or our C value. So the other two okay. The other two represent our A and our B. Okay, so 6.6 squared is equal to 400 or 43.56 plus 11 squared, which is 121, and 13 squared is 169. So I go 43 plus 121. That equals 164.56, which does not equal 169. All right, so therefore, this one is not tangent to the circle. Okay, and so that's what you're going to want to do for these three. Right, in order for this relationship to hold true, right, in order for this to be a tangent, AB, okay, because AB is the one that's touching our circle on the outside exactly once, okay, in order for AB to be a tangent, this equation has to equal out, okay? So do the same thing for these ones. Okay, so you'll go 16 squared plus 12 squared is equal to 20 squared, okay? Check to make sure that works out, and then do the same thing for this one as well. So you're going to go 15 squared plus 11.4 squared is equal to 19 squared. Make sure that checks out, okay? And that'll be your homework for that section right there. So determine if line AB is a tangent, okay? All right. Try those ones as well. Okay, for the last part, tangents to a circle from a point. Next, we'll do one of these examples. All right, so find the line segment indicated. Assume that the lines which appear to be tangent, are tangent. Okay. So in this case, okay. So find the segment length indicated and assume that lines which appear to be tangent are tangent. Okay. So what do we know? Let's try number 6, okay? So I think the other two are kind of straightforward. 6 seems a bit tricky. All right? So it might not seem obvious at first, But what is the length of this side right there? Well, because these are radius, if that's 1.5, that means that is also 1.5. Okay? Which means this whole piece right here is 2.5. So in order to find this length, we'll call x, okay, we have to use, again, Pythagorean's theorem. So this one is located directly across from our right angle. So again, we're going to put 1.5 squared plus x squared is equal to 2.5 squared. 1.5 squared is 2.25 plus x squared is equal to 2.5 squared is equal to 6.25. Okay, and then solve for x. Squared is equal to 4. Take the square root. X is equal to 2. Okay? That's what you want to do for those ones. All right. Take a minute to kind of think that one over. And that's what you're looking at. Okay? So tangents to a circle from a point. So all tangents from an exterior point to a given circle have the same length. Okay? So that's what we're trying to prove. Now, because we already just discussed it, we know that this length is equal to this length, right? Because of the radii. And so it says, in the following tangents BC, B are drawn. Why can we say that ACB is congruent to ADB? All right, so let's think about that for a second. So we know these two sides are the same. They give us a right angle, okay? Now let's take a look at these triangles here. How could I prove these two triangles are congruent? Okay, what theorem have we learned involves a right angle? Okay, there's only one. In order to prove two triangles are congruent, all right, and they have a right angle, because technically we can't say this, right? We can't say angle side side, right? We are not allowed to do that, okay? This one is not allowed. So, that being said, because we can't use angle side side, because we have a right angle, I can say that by hypotenuse leg, triangle ACB is congruent to triangle ADB, okay? By hypotenuse leg, okay? We got this side is the same, they got two right angles, and then we got this one in the middle here. That shared side, right? They both share side BA, so therefore by hypotenuse leg, I can say that these two triangles are congruent. Okay, so why does this prove that the tangents have the same length? Well, by CPCTC, we can say that any corresponding part of those triangles are congruent. So therefore, CB is congruent to DB. And therefore, tangents have the same length. Now again, this only applies when all tangents drawn from an exterior point to a given circle will have the same length. Okay, so in this case, B was drawn to the circle, okay? So we're starting at B, and then B went to C and D here. So these two lengths will always be the same, okay? Based off of the distance from B, okay? I'll say it one more time. The distance from B is the same from C. The distance from B is the same to point C to point D, okay? All right. So let's do a couple more examples and we're out here. So an example in the diagram below, okay? Does that make a lot of sense here, guys? I don't know if I said that quite clear. I know you guys can't answer, but basically the idea is behind this is that when you got this fixed point B here, okay, it's just floating out in space, right? You take the first point and you draw it over to C, okay? So there's our tangent line, okay? It meets that letter C once, okay? Then to meet the other, to get from B to D, okay? Again, we're just touching that center once. So these two rays right here, okay? They both end up touching the circle at the same distance apart. Okay? So that's what that means. All right. So that being said, let's continue on here. So in circle O and inscribed, circle O is inscribed in triangle ABC. So that is crap. Okay, let me read it again. So in the diagram below, circle O is inscribed in triangle ABC. So that is tangent at points D, E, and F as shown. Okay, so it's tangent, so that means this distance is going to be the same. Get a different color here. This distance is going to be the same. And then finally, this distance is going to be the same. Okay? So it says AD is 4, BF is 6, and CE is 7. So that means if this is 7, that's 7. If that is 6, that is 6. If that is 4, that is 4. So now we have to do here, guys, is add it up. So 11, 10, 13. So 10 plus 13 is 24, plus 11 is 35. This is the perimeter. Okay? So for homework, I want you to try these and the rest of those. Okay? And the rest of these. So again, what we had to kind of take away from this is that your tangent lines are perpendicular to your radius. All right? And that all tangent lines are congruent. So this one here, these tangent lines are congruent, those tangent lines are congruent, and those are congruent. Okay? And so kind of like a puzzle, you're going to have to piece all those together. All right? So good luck, you guys, and I'll talk to you.